Greetings. My name is Ahmed and my paper is MCS, Multiple Classifier System to predict the churners in the telecom industry. I'm a PhD student at National University of Sciences and Technology, Islamabad, Pakistan. The problem we'll discuss today is customer churn. What is churn? Churn describes the subscribers who terminate their relationships with their service providers and move their subscription to the competitor due to some new incentives offered through advertisements, etc. Customer churn prevention is a major part of the customer relationship management in any business. Same is the norm in telecom industry, where due to immense competition among the telecom carriers, there is a dire need for churn management for the operators to retain their current subscribers. Churn prevention is an important factor as the cost of customer acquisition is much greater than the cost of customer retention. So we conclude that a multiple classifier system is introduced that is applied on two datasets. One is a publicly available dataset and the other is a private dataset collected from a South Asian wireless telecom operator. The results show that the proposed framework outperformed the current best results, giving an accuracy up to 97%. Our solution to the problem is machine learning. Machine learning techniques have vastly been applied in predictive analysis that can provide accurate classification of the churners and the non-churners. Recently, ensemble techniques such as voting, stacking, bagging, and boosting are employed with greater success as they consider using a combination of learners instead of one, that in turn increases the classification rate. Now on comparison of the techniques applied in literature on both public and private datasets, we can see that traditional techniques like decision trees, neural networks only give satisfactory results, while the ensemble techniques have improved the accuracy significantly in comparison. Two datasets have been used in this study. One publicly available dataset from the UCI machine learning repository that has 5,000 samples and 20 attributes with 14.3% churn rate. And the second dataset is used from real-life data collected from a major wireless telecom operator in South Asia. It has 2,000 samples with 50% churn rate. Looking at the datasets in detail, we can see the features used that include customer demographic data like state, area code, call detail records, number of voicemail messages, total number of minutes or minutes of calls, and customer account information. In the private dataset, similar attributes have been used like call detail records, customer account information, and usage details, which include favorite other networks and data volume. Now, MCS was built following the overproduce and choose approach. This system is a hybrid of the boosting and stacking technique. The labeled dataset is passed on to the MCS system, the pre-processed dataset. Firstly, the weights are assigned to each sample of the training dataset. and passed on to the multiple classifier system. This weighted dataset is passed on to the stacked model. This stacked model has two levels. Level 0 has 3 stacked classifiers or stacked learners, namely neural network, decision tree, and k-nearest neighbor, that give their output predictions on this weighted dataset. These predictions are used to make a meta dataset along with the features previously used in the original dataset, and is passed on to the level 1 meta learner. This learner produces the output for the first iteration. In the second iteration, the learning error is calculated and the weights are updated up till the t iterations. Once we have the output for all the t iterations, a majority vote is taken on the predictions of the outputs to get the Churners. This is the multiple classifier system. Now when we see the performance of the multiple classifier system, the result of MCS in comparison with the traditional classifiers on dataset 1 and 2 show that the accuracy increases in case of MCS with both the datasets. MCS was also compared with the best proposed techniques to date. We can see that the proposed framework gave the best performance as compared to the literature. The remarkable result achieved with this amalgamation proves the strength of ensemble techniques. In the future, further combinations or hybrids of the classifiers can be explored to improve the performance of private datasets as well. Thank you. If you're interested in my research work, please, or have any other queries, please contact me at mehreenmcs@gmail.com or follow me on LinkedIn, ResearchGate, and visit my research website, codeteam.com.